Alright class, so here is a video to go over the review just in case you didn't make it to any of the study sessions. To start off, we're going to go ahead and talk about the scientist, and all of these scientists and what they did can be found on the chemistry website. So you can just go to that. They're all there for you, everything. So even their experiments, what they discovered, if there's no experiment there, just make a line through it. Okay. So the next thing that we're going to talk about is going to be the isotope and calculating atomic numbers and from the periodic table. So tin, also known as Sb, the atomic number is going to be 50. The mass is going to be 118.71. Number of neutrons. Remember, we just take the mass number minus atomic number. And then the number of protons is the same as the atomic number, and the number of electrons is the same. Okay, so then if we have tin 121, 121 is going to be the mass number. Atomic number stays the same. So for 116, that's the mass number. Protons and electrons are all going to be the same. Okay, so the only thing that's different is going to be the number of neutrons. So let me grab my calculator. Number of neutrons for the first tin is going to be 69. Number of neutrons for the second one is going to be 71. And the number of neutrons for the last one is going to be 66. So go ahead and do these next three by yourself, and then you can check the answer key that's posted online as well. The next ones that we're going to talk about is going to be looking at ions and their charges. Okay, so we've got to look at the number of valence electrons. And if you remember, you go to the website here, pull this up. And periodic table review. Okay, right here we have our blank periodic table for a lecture. So I'll pull this one up. So valence electrons are going to go along with the groups that they are in. We have our pen. So this is group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. For valence electrons, I'm going to go ahead and put them in a different color, and I'm going to put, for valence electrons, I'll put them in blue. Anything in group 1 is going to have valence electrons. It's going to have one valence electron. Anything in group 2 will have 2. We skip this block. Anything in group 13 will have 3 valence electrons. 14 will have 4, 15 will have 5, 16 will have 6, 17 will have 7, and 18 will have 7, sorry. And we'll have 8. So if we look at bromine, it's in group 17, so we know it has to have 7 valence electrons. So 7 valence electrons. Then if we go back and look at rubidium in our periodic table, rubidium is number 37, Rb. It's going to be in group 1, so it has to have 1 valence electron. Valence electron. Now, charge of ions. We talked about the charge of the ions the other day when I was drawing on the periodic table that was up on the board. And the charges are just a little bit different. Okay, so the charges is going to be the charge of the ions that they're going to make. So anything in group 1, so charge charge Okay, so anything in group 1 is going to have a +1 charge. Group 2 will be a +2 charge. Group 3 will be a +3 charge. There's no charge for anything in group 14, no charge. Group 15 will actually be a -3. Group 16 will be a -2. And group 17 will be a -1. And anything in group 18 is not going to have a charge because it's not going to want to make an ion. Remember, negative ions are called anions. And positive ions are going to be cations. So let's go back to our worksheet. So charge of the ion, anything, if it's 7, it's going to be, we know the charge is going to be a negative because it's a -1 ion. Rubidium is going to be a +1. So this is going to be an anion, and this is going to be a cat ion. I always remember cat looks like a plus. This is a plus. Outer shells. Outer shells, we know that by looking at what period they are in. So we have 1, 2, 3, 4, 5, 6, 7. So bromine is in group 4, and then rubidium is in 5, so that's going to be our periods. So we have 4 and 5. Okay, next one is going to be the percent abundance question, and this question is actually on your test, same numbers and everything, so hopefully you pay attention and you understand. To start off, this is going to be exactly like our Beanium lab. So when we're looking at calculating the percent of atoms in each isotope, what we're going to have to do is we're going to have to add all these numbers together. We're going to add each one of those numbers together, so we'll have the total, and we'll actually have to go ahead and end up dividing the number of atoms by the total. So I'm going to do a quick little review for you on how to add and subtract exponents and multiply, so it's going to be all together. So let's start off with, we have 3.349 times 10 to the 29th. I want to make all of these times 10 to the 29th. So if I want to make this number right here smaller, that means this number has to get bigger. So we're going to move it over 1 to the right to make it this number bigger, making that number smaller. Times 10 to the 29th. And then we should get 1.6744 times 10 to the 29th. So we'll add these all together, which should get us 16.7434 times 10 to the 29th. But that is not in correct scientific notation. We need to move this over 1, so we're making 16 into 1.6, so making this smaller is going to make this bigger. So we should get 1.67434 times 10 to the 30th, which is a really, really big number. So the next thing we have to do is we're going to take this number right here. So it's going to be 3.349 times 10 to the 29th divided by 1.67434 times 10 to the 30th. So we just divide these numbers here. We get 1.623 times 10 to the, I'm going to subtract these, -1. Next one, we'll do 1.172 times 10 to the 30th divided by 1.67434 times 10 to the 30th. Divide these again. So we should get 3.613 times 10 to the, oh, no, wrong answer, sorry. Wrong answer. Erase. Wrong answer for both of these. Sorry guys, looking at the wrong thing. So, you divide these, you should get 2.000 times 10 to the negative 1. And then this one you should get 7.000 times 10 to the negative 1. Plugged into my calculator wrong. Last one, I'll let you guys do this one by yourself to make sure that you know what you're doing and check it with the answer key. So the next part, so finding the mass of the single atom of each isotope. So this one, what you're going to have to do is we have the mass here. You're going to have to take the mass divided by the number of atoms. So I'm going to put this in a scientific notation, so it'll be, oh, wow, jumped around. It'll be, okay, pen. Okay, so this one will be 5.436 times 10 to the first divided by 3.349 times 10 to the 29th. So again, we divide this, gives us 1.623 times 10 to the negative 28th. Subtract these. So if we have 1 minus 29, that's where we get the negative. Next one we should have 4.234 times 10 to the negative, or times 10 to the 1, divided by 1.172 times 10 to the 30th equals 3.613 times 10 to the negative 29th. Okay, I'll let you do this last one again to make sure that you know what you're doing. Check it with the answer key. And then the last step of this problem, okay, what we need to do is we're going to calculate it for each isotope. So what we have to do is we're going to take this number, multiply it by this number, and we should get an answer, and we're going to add them all together. So we're going to take 2.000 times 10 to the negative 1 multiplied by 1.623 times 10 to the negative 28th. Should get 3.246 times 10 to the negative 29th. Again, we just multiply these numbers here. We're going to add the exponents together. And then we are going to do the next set of numbers. 7.000 times 10 to the negative first. Times 3.613 times 10 to the negative 29th. Then we actually get 25.291 times 10 to the negative 30th. But we need to move this over, making this number smaller, so this has to get bigger. So it's going to be 2.5 times 10 to the negative 29th. Then I'm going to let you do the last one by yourself. Then after you get the last one, I'm going to let you go ahead and add these all together. So you're going to add this one plus this last one that you multiply, and then you should get the final answer. And then you can go ahead and check that with the answer key as well. The next part, okay, looking at your periodic table, you should be able to tell me how the electronegativities go and how the trends work with ionic radius, atomic radius, atomic mass, all of that good stuff. So we know electronegativity. If we have the periodic table here, electronegativity is going to increase as we go over and decrease as we go down. Radius, remember, is going to be different, or atomic size, which would be the radius. Okay, remember this is going to decrease as we go down, but increase as we go bigger. And ionic radius is going to do the same. It's going to decrease as we go over and increase as we go down. Ionization energy is going to be the same as electronegativity. That is going to increase as you go over and decrease as you go down. So if we look at our periodic table, if we have